Welcome to our deep dive, everyone. We're going to be looking at some amazing stuff today with the James Webb Space Telescope.
Yeah, it's quite a piece of tech.
It really is. And you've been able to translate some stuff for us that is,
Yeah, in another language.
right. So you'll be sharing some insights from that.
Absolutely.
Cool. Well, this telescope is making waves, incredible images, and discoveries. So what is so special about it?
Well, the James Webb Space Telescope, or JWST as it's known, it's not just an upgrade from the Hubble.
Right.
It's a whole new way of seeing the universe thanks to its ability to see infrared light.
Okay. So Hubble, it's given us those iconic images for what feels like forever now. So what's the big deal with infrared? Why is the JWST built around that?
Well, think of infrared light as having a superpower. It can penetrate those dust clouds which block visible light.
Ah,
Imagine trying to see through a dense fog.
okay. Yeah.
That's what astronomers face when they're observing certain areas of space, and the JWST cuts right through that.
So we finally get a clear view of those hidden areas. What are we hoping to find in there?
Well, one of the big missions of the JWST is to find the very first stars, the ones that formed after the Big Bang.
Wow.
And because the universe is expanding, the light from these distant stars has stretched over time.
Right.
It's a phenomenon called redshift. And the stretched light has shifted into the infrared spectrum.
Hmm.
So the JWST and its infrared vision is crucial for detecting them.
Oh, so it's like a time machine to look back at the universe's baby pictures. So finding these stars could actually confirm the Big Bang Theory.
Absolutely. And these first stars, they're the cosmic grandparents of everything we see today.
Wow.
They created the heavier elements like carbon and oxygen that eventually formed planets and, well, us.
Talk about an origin story. To see that far back, I mean, those stars must be incredibly far away.
The furthest known galaxy is called GNZ11, and it's so distant that its light has been traveling for over 13 billion years to reach us.
13 billion years.
And the JWST has the potential to see even further.
Okay, my mind is officially blown. Let's shift gears a little bit and talk about the JWST itself. So this isn't just a marvel of science, it's an engineering feat.
Absolutely.
I've read that one of the biggest challenges was its massive primary mirror.
Absolutely. The primary mirror is over 21 feet across, and it's made up of 18 hexagonal segments that had to unfold perfectly in space.
Right?
And that design was crucial for both its power and for fitting it inside the rocket for launch.
I can't even fold a fitted sheet properly.
Yeah, right.
So why the hexagonal shape and what are they made of?
Well, the hexagonal shape allows for a large circular mirror, but one that can be folded compactly for launch.
Ah, okay.
And those segments are made of beryllium.
Beryllium.
It's a lightweight but incredibly strong metal,
Uh-huh.
and it's coated with a thin layer of gold to help reflect infrared light.
Wow. So it's not just a telescope, it's practically a work of art. And I imagine those delicate mirrors need protection out in space. The source material mentioned micrometeoroids.
Yeah, those are tiny space bullets. And the JWST has already taken a few hits.
Really?
One impact left a small crater on one of the segments. But luckily, the engineers designed the mirror segments to be individually adjustable
Oh,
so they can compensate for this kind of damage.
that's a relief. Speaking of precautions, the source material also mentioned that they actually built multiple mirrors.
Yeah. Constructing those mirrors, it's incredibly precise and it's time-consuming, takes years to complete. So they often create multiple mirrors as a precaution. Even Hubble had a spare mirror, just in case something went wrong during its construction.
That's some serious forward thinking.
Mm.
But with all these delicate components, how does the JWST survive the harsh environment of space?
Well, one of the biggest challenges is keeping the telescope extremely cold.
Okay.
We're talking a frigid negative 266 degrees Celsius. This is essential because the faint infrared signals we're trying to detect are easily overwhelmed by heat.
That's colder than anything I can imagine. How do they achieve that in space?
Essentially, they launched a giant refrigerator into space.
A refrigerator.
The JWST has a cooling system called a cryocooler filled with liquid helium,
Right.
which keeps the instruments at their required operating temperature.
Liquid helium. Isn't that the stuff that makes your voice sound funny?
It is indeed. However, word of caution, while it might be amusing to hear someone's voice change, inhaling pure helium is incredibly dangerous.
Oh, yeah.
It can cause suffocation, so definitely not something to experiment with.
Noted. Back to the JWST's chilly situation.
Right.
If the instruments are inside this super cold cooler, how do they actually see anything?
Well, that's where the JWPS sunshield comes in. It's a massive 5-layer shield about the size of a tennis court that protects the telescope from the sun's heat and light. This shield is incredibly durable, designed to withstand high-speed micrometeoroid impacts.
A tennis court in space.
It's hard to even imagine the scale.
Yeah, that sunshield must be one tough cookie.
It has to be. Remember, the telescope's survival depends on maintaining that incredibly low temperature, and even a small tear in the sunshield could jeopardize the entire mission. Speaking of high stakes, the deployment process after launch was a nail-biting experience. It took a full month, involved over 300 steps, any of which could have turned the JWST into a very expensive piece of space debris.
300 steps, that's terrifying. How did they manage to pull it off?
Well, it was a testament to meticulous planning and testing. NASA rigorously tested every step of the deployment process on Earth, running countless simulations to ensure everything would work flawlessly in space.
Right.
The first things to deploy were the solar panels and communication systems, followed by the intricate unfolding of the sunshield and the mirror segments.
It's amazing that it all worked. So where is this incredible telescope located now?
The JWST is stationed at a special point in space called the Second Lagrange Point, or L2.
L2.
It's about 1.5 million kilometers from Earth.
Lagrange point. That rings a bell. Didn't we learn about those in physics class?
You might have.
Yeah.
Lagrange points are special locations in space where the gravitational forces of two large bodies, like the Earth and the Sun, create a sort of equilibrium. There are actually 5 Lagrange points in the Earth-Sun system.
Wow.
It's a concept first calculated back in the 18th century.
So being at L2 is crucial for the JWST's mission, but why?
It's a sweet spot for several reasons.
Okay.
It keeps the telescope out of Earth's shadow, ensuring continuous power from its solar panels. Plus, it allows the JWST to maintain a stable temperature because it's always facing away from the sun. This minimizes fuel consumption for adjustments,
Right.
allowing the JWST to focus on its observations.
It's like finding the perfect parking spot in space.
It is.
But all of this complex technology and precise positioning, it must have taken a massive global effort to get the JWST up and running right.
Oh, you're absolutely right. This was a truly global endeavor showcasing the power of international collaboration in space exploration. The European Space Agency, they contributed the powerful Ariane 5 rocket that launched the telescope. And the Canadian Space Agency provided key instruments.
It's inspiring to see the world come together for such an ambitious project. But once it's out there collecting data, how does it all get back to Earth?
Well, the JWST has a 58.9 gigabit buffer where it stores images before transmitting them back to Earth.
Okay.
It sends about 55 gigabytes of data daily to a global network of receiving antennas in California, Australia, and Spain.
55 gigabytes of data per day. That's a lot of information.
It is. And all of that data is then sent to the Space Telescope Science Institute in the United States, where it's processed and transformed into the stunning images that we see.
It's mind-boggling to think about this constant stream of information flowing from a telescope millions of kilometers away.
Yeah.
It's like a window into the past, revealing secrets of the universe. And speaking of those images, let's talk about some of the incredible things that the JWST has captured. These images have been making headlines everywhere.
They have. It's giving us an entirely new level of detail and clarity, unlike anything we've seen before. Comparing these images to the older Hubble images truly highlights the advancements. For example, the image of SMACS 0723.
Right.
It's a massive galaxy cluster, offered a look back in time, showcasing thousands of galaxies as they were 4.6 billion years ago.
I remember that image. It was unveiled by President Biden himself. It looked like a jewel-encrusted tapestry. What was so special about that particular image?
Well, that image showed us thousands of galaxies, some so distant that their light has been traveling for 4.6 billion years to reach us. We're essentially looking back in time to a period before our own solar system even existed.
Wow.
And those 6-pointed starbursts you see in the images?
Yeah.
That's a telltale sign of a JWST image, a result of light diffracting around its hexagonal mirror segments. It's a striking contrast to the 4-pointed starbursts we see in Hubble images, caused by its secondary mirror supports.
It's like a cosmic fingerprint, revealing which telescope captured the image. What other cosmic wonders has the JWST captured?
Well, one of the most stunning examples is the image of the Carina Nebula,
The Carina Nebula.
a vast and dynamic star-forming region. Compared to a Hubble image of the same area, the JWST image is like night and day. We see a breathtaking tapestry of gas and dust illuminated by newborn stars, with a level of detail and color that Hubble simply couldn't achieve.
It's incredible to think about those images capturing events that happened millions, even billions of years ago.
Yeah.
It must be like watching a cosmic time lapse. What other cosmic portraits has the JWST added to its gallery?
Well, there's the image of Stephan's quintet, a group of 5 interacting galaxies.
Yeah.
The JWST image, it reveals intricate details, including shockwaves and tidal tails, showcasing the dramatic dance of these galaxies as their gravity pulls at each other.
It's a cosmic ballet captured in stunning detail. And speaking of dramatic events, didn't the JWST also capture an image of a dying star?
Yes, the Southern Ring Nebula. The JWST peered through the clouds of gas and dust to reveal the dying star at its heart, shedding its outer layers into space.
Wow.
And its infrared vision, it unveiled a surprise: a binary star system at the nebulous center, previously hidden from view.
A hidden companion star. It's amazing how the JWST is revealing these secrets hidden within these familiar cosmic objects.
It is.
But what about the colors in those images? Are those the actual colors of those distant objects?
Well, the colors in JWST images are representative,
Okay.
meaning they're based on the wavelengths of light detected, but enhanced to showcase details and make the images more visually engaging. Different colors often indicate various elements present, the distances of objects, and their temperatures.
It's like a cosmic decoder ring where colors unlock hidden clues about the universe. And we've only just begun to explore what the JWST can do. We've seen those distant galaxies and nebulas, but it's also making waves in the study of exoplanets.
Absolutely. One of the JWST's groundbreaking capabilities is its ability to analyze the atmospheres of planets orbiting other stars. This is a game changer for our understanding of exoplanets and the search for life beyond Earth.
Wait, analyzing atmospheres from millions of kilometers away? How is that even possible?
It comes down to how light interacts with molecules in an atmosphere. When a planet passes in front of its star, some starlight filters through the planet's atmosphere. And the JWST can analyze the spectrum of this light, detecting the presence of specific molecules like water, methane, and carbon dioxide.
So it's like a cosmic fingerprint scanner for atmospheres. How does this help us find life?
Well, certain molecules like oxygen and methane can be indicators of biological activity. Finding them in the right combinations could suggest that life might exist on that planet.
That's incredible. And I read that the JWST has already made some surprising discoveries in this area, particularly with a planet called WSP-96b.
Ah, yes. WASP 96b. It's a fascinating case. It's a hot Jupiter-like planet that whips around its star in just 3 days.
3 days.
Yeah. Previous observations suggested it was a dry, scorching world.
Right.
But the JWST detected water vapor in its atmosphere.
Water vapor on a planet that orbits its star every 3 days. That's unexpected.
It certainly is.
Yeah.
While WASP 96b is still unlikely to harbor life as we know it,
Right.
the presence of water vapor opens up new questions and challenges our previous assumptions.
It seems like every new discovery from the JWST raises even more questions. It's a truly exciting time for space exploration. But with all this incredible technology and progress, what's next? Is there already a successor to the JWST in the works?
There is. The next generation space telescope is called the Nancy Grace Roman Space Telescope, and it's slated to launch in 2025.
That name sounds familiar.
Nancy Roman was a remarkable figure in space exploration. She was NASA's first chief astronomer and played a key role in developing the Hubble Space Telescope. She was known as the Mother of Hubble, a fitting tribute to her legacy.
That's a wonderful way to honor her contributions. So the Roman telescope will carry on the legacy. But what will its mission be?
Well, the Roman telescope will build upon the JWST's work, focusing on wide field surveys of the universe, studying dark energy, and searching for exoplanets. It will have a field of view 100 times greater than Hubble, allowing it to capture these vast cosmic landscapes.
100 times greater. That's an incredible leap in our ability to see the universe. I can only imagine the discoveries that await us. But for now, we're still in the era of the JWST, and there's so much more to explore and learn from this remarkable instrument.
Indeed. The JWST is a testament to human curiosity and our drive to understand our place in the universe. It's a reminder that there's still so much out there waiting to be discovered, and the future of space exploration is filled with endless possibilities.
It's enough to make you feel both incredibly small and incredibly connected to something much larger than ourselves.
It's about looking up at the night sky and realizing that we're part of something truly extraordinary, something that's been unfolding for billions of years. And the JWST, with its remarkable vision, is giving us a front row seat to that cosmic spectacle.
We've covered a lot of ground in this deep dive, from the JWST's mind-blowing engineering to its groundbreaking discoveries. And this is just the beginning of our exploration.
There's so much more to unpack. We'll be back soon to delve deeper into the James Webb Space Telescope and the remarkable discoveries it's making.
Welcome back to our deep dive into the James Webb Space Telescope. We're picking up where we left off, exploring the amazing discoveries and technological marvels of this incredible instrument. You know, when we talk about the JWST's ability to see faraway objects, it's easy to get lost in the sheer scale of it all.
It's true, we're talking about observing objects so distant that their light has been traveling for billions of years to reach us.
Billions of years.
Yeah.
It's mind-boggling.
Yeah.
And that's where the concept of redshift becomes so crucial. Right. Redshift. We touched on it briefly in part 1,
Yeah.
but I think it's worth diving a little deeper.
Absolutely.
So redshift is this idea that as the universe expands, light from distant objects gets stretched,
Right.
causing it to shift towards the red end of the spectrum.
Exactly. And the farther away an object is, the faster it's moving away from us, and the more its light is redshifted. That's why the JWST's infrared capabilities are so important.
Right.
It allows us to see those incredibly redshifted objects, the ones that are so far away, their light has stretched beyond what our eyes can see.
So it's like the JWST is giving us a deeper view, not just into space,
Yeah.
but also into time,
Exactly.
allowing us to see the universe as it was billions of years ago.
I find it fascinating that the JWST was initially planned to launch back in 2010,
Right.
but faced numerous delays.
It could.
What caused those setbacks?
Well, the JWST is the most complex and ambitious space telescope ever built.
It pushed the boundaries of technology and required meticulous planning and a global collaboration of scientists and engineers. The delays were partly due to budgetary constraints
Yeah.
and the sheer complexity of the project.
It's like trying to build a super sophisticated, one-of-a-kind machine with a global team and a constantly shifting budget.
Exactly.
I can see how that would lead to some delays. And during those delays, the Hubble telescope, which was supposed to retire,
Right.
had to keep working.
It did.
It's like the seasoned veteran who gets called back for one more mission because the rookie isn't ready yet.
That's a great analogy, and Hubble certainly proved its worth during that time. It even had its own share of challenges early on. Remember the issue with its faulty mirror?
Oh, right. Shortly after Hubble launched in 1990, they discovered a flaw in its main mirror,
Yeah.
causing blurry images. Thankfully, a repair mission in 1993 fixed the problem.
Right.
And Hubble went on to capture those iconic images we know and love.
Absolutely. It's a testament to human ingenuity and perseverance.
It is.
And speaking of ingenuity, let's talk about the JWST's unique design,
Yeah?
particularly those striking hexagonal mirror segments.
Yes.
Why did they go with that shape, and how do those segments work together to create a single clear image?
Yeah, those hexagonal segments are definitely eye-catching.
No.
What's the story behind them?
Well, the hexagonal shape was a clever solution to several challenges.
Okay.
First, it allows for a large mirror to be folded compactly for launch,
Oh.
fitting snugly inside the rocket. Trying to launch a massive, solid, round mirror would have been impossible.
That makes sense.
Mm.
But how do those individual segments work together as one giant mirror?
Well, each segment can be individually adjusted with incredible precision.
Wow.
Think of it like a giant puzzle, where each piece can be moved ever so slightly to create a perfectly smooth surface.
Okay.
Light from distant objects hits those 18 segments, which then reflect the light onto a secondary mirror.
Right.
From there, the light is focused onto the telescope's instruments, which capture those amazing images.
It's like a carefully choreographed dance of light bouncing between mirrors.
It is.
It's incredible how they managed to design a system so complex, yet so precise. And what about the colors we see in those images?
Yeah,
Are we seeing the actual colors of those distant galaxies and nebulas?
that's a great question. It's important to remember that the colors in JWST images are representative.
Okay.
They're based on the wavelengths of light detected by the telescope,
Right.
but are enhanced and processed to make the images more visually appealing and to highlight specific features.
So it's like an artistic interpretation of a scientific data set, using color to reveal details that might otherwise be invisible.
Precisely. And those colors can tell us a lot about the objects we're seeing. For example, different colors can indicate different elements present in a nebula, or the temperature variations within a galaxy.
It's like having a cosmic decoder ring, where colors unlock hidden clues about the universe.
It is.
Now, one of the most exciting things about the JWST is its ability to study exoplanets, those planets that orbit other stars.
Right.
And remember, the source material mentioned the telescope's ability to detect water on these distant worlds.
Yes.
That's pretty mind-blowing.
It is. Finding water on other planets is a huge deal in the search for life beyond Earth. Water is considered a key ingredient for life as we know it.
Right.
So detecting it on other planets is a tantalizing clue.
Okay, so how does the JWST actually detect water on planets that are light years away?
It all comes down to a technique called spectroscopy.
Spectroscopy.
When starlight passes through a planet's atmosphere,
Right.
certain wavelengths of light are absorbed by the molecules in that atmosphere. Think of it like a barcode revealing the chemical fingerprint of that planet's air.
So the atmosphere leaves its signature on the starlight,
Right.
and the JWST can read those signatures to identify the molecules present.
Exactly.
That's incredible. And one of those molecules is water.
Exactly. Water molecules absorb specific wavelengths of light, leaving a unique fingerprint that the JWST's instruments can detect.
It's like having a long-distance chemical sensor sniffing out the composition of alien atmospheres.
It is!
That's simply amazing. The JWST truly is a game changer, pushing the boundaries of what we thought was possible in astronomy.
Absolutely. And we're only just scratching the surface of what it can do. The JWST is expected to operate for at least 10 years.
Wow.
And during that time, it's likely to make countless more discoveries, potentially even challenging our understanding of physics and cosmology.
It's like opening a new chapter in the book of cosmic exploration.
Oh.
Now, I remember the source material mentioned that the JWST is located at a special point in space called the second Lagrange point,
Right.
or L2.
Yes,
It's not just orbiting Earth like Hubble, right?
that's right. The JWST is stationed at L2, which is about 1.5 million kilometers from Earth. Remember, Lagrange points.
Yeah.
Those special locations where the gravitational forces of two large bodies, in this case the Earth and the Sun, balance out,
Right.
creating a sort of gravitational sweet spot.
Right. We talked about those briefly in part 1. But why is L2 such a crucial location for the JWST?
Well, L2 offers several advantages for the telescope. First, it's far enough from Earth to minimize interference from our planet's heat and light, which is essential for the JWST's sensitive infrared instruments.
Right. Keeping cool is crucial for detecting those faint infrared signals. But isn't being so far from Earth a problem for communication and data transfer?
It's a valid concern, but NASA has it covered.
Oh.
The JWST has a powerful antenna that transmits data back to Earth at a rate of about 55 gigabytes per day.
55 gigabytes per day. That's a massive amount of data.
It is.
Where does all that information go?
Well, it's received by a network of giant antennas around the world called the Deep Space Network. From there, the data is sent to the Space Telescope Science Institute, where it's processed and made available to scientists worldwide.
It's amazing to think about this constant flow of information coming from a telescope millions of kilometers away.
It really is.
And all of this is made possible through human ingenuity and collaboration, right?
Right. Absolutely. The JWST is a testament to the power of international teamwork. It was a joint effort involving NASA, the European Space Agency, and the Canadian Space Agency. Scientists and engineers from around the world came together to make this incredible project a reality.
It's a reminder that science transcends borders, bringing people together to explore the universe and uncover its secrets. And speaking of secrets, the source material mentioned the JWST's potential role in understanding the origins of the universe.
Yes.
That's a pretty ambitious goal.
It is. One of the JWST's primary missions is to observe the very first stars and galaxies that formed after the Big Bang.
Wow.
These objects are so distant and faint that they've been beyond the reach of previous telescopes.
Right.
But the JWST, with its infrared vision, is finally able to peer back to that era, capturing the faint light from those ancient objects.
So it's like looking back in time, witnessing the universe's infancy, seeing how those first structures formed and evolved.
It is.
It's a cosmic detective story.
Exactly. By studying these early stars and galaxies, scientists hope to gain insights into the processes that shape the universe as we know it, from the formation of the first elements to the emergence of those incredible structures we see today.
The JWST is like a time machine,
Yeah.
allowing us to witness those pivotal moments in the universe's history. It's both humbling and awe-inspiring.
It really is.
We've covered so much ground in this deep dive,
We have.
but there's still so much more to explore. The JWST is a true testament to human ingenuity and curiosity.
And as we continue to receive those breathtaking images and groundbreaking data, we're reminded of the vastness of the universe and the endless possibilities for discovery. It's a journey of exploration, a quest for knowledge, and a celebration of the human spirit's drive to understand the cosmos.
And with each new image, each new piece of data, the JWST is rewriting our understanding of the universe and our place within it.
It is.
But before we move on to our final part, I think it's important to step back and consider the bigger picture. We've talked about the technology, the discoveries, the potential for future revelations.
Right.
But what does it all mean? Why should we, as humans here on Earth, care about a telescope millions of kilometers away, peering into the depths of space?
That's a fundamental question. It's not just about gathering data or confirming theories. It's about understanding our place in the universe.
Yeah.
It's about seeking answers to those existential questions that humans have pondered for centuries. Where did we come from? Are we alone? What is our destiny?
It's about that innate human desire to explore, to push the boundaries of knowledge, and to connect with something larger than ourselves.
Absolutely.
And the JWST, with its remarkable capabilities, is helping us do just that.
It is.
As we delve deeper into those cosmic mysteries, as we unravel the secrets of distant stars and galaxies, we gain a new perspective on our own planet.
Right.
We begin to see that we're part of something truly extraordinary. Our own story is interwoven with the story of the universe itself.
It is.
It's a story of creation, of evolution, and of endless possibilities. The JWST is helping us to write the next chapter of that story, and we're excited to see what unfolds next. Join us for the final part of our deep dive as we continue our exploration of the James Webb Space Telescope and the remarkable discoveries it's making. Welcome back to the final part of our deep dive into the James Webb Space Telescope. It's been an incredible journey so far, exploring the telescope's groundbreaking capabilities and the amazing discoveries it's already made.
It really is revolutionary. And one of the most amazing things is just the amount of data this thing generates.
Yeah, 55 gigabytes every day,
Yeah.
a constant stream of information,
Yeah.
millions of kilometers away. It's incredible.
It is. And to process all of that information, it takes a global team of scientists working around the clock. And the source material that you provided really highlighted that collaboration. Remember, the JWST isn't just a NASA mission, it's a partnership
Right.
involving space agencies from all over the world, including the European Space Agency and the Canadian Space Agency.
It's really inspiring to see this international collaboration. All these scientists from diverse backgrounds coming together to analyze this treasure trove of data. It's like a giant puzzle, and everyone's bringing their expertise to the table to piece it all together. And speaking of looking ahead, there's already a successor to the JWST in the works, right?
That's right, the Nancy Grace Roman Space Telescope. It's also an infrared telescope.
Wow.
It's scheduled to launch in 2025. It's named after Nancy Roman, a remarkable woman. She was NASA's first chief astronomer and a driving force behind the Hubble Space Telescope.
Mother of Hubble.
Exactly, a fitting tribute.
Yeah. So how will the Roman telescope build upon that legacy of the JWST?
Well, it will have a much wider field of view than the JWST, so it can capture vast areas of the sky in a single image. Imagine going from a telephoto lens to a wide-angle lens.
Okay, yeah.
This is going to be incredibly powerful for these large-scale surveys of the universe, mapping out the distribution of galaxies, searching for distant supernovae.
And will it be able to contribute to our understanding of dark energy? And that's one of those cosmic mysteries that always makes my head spin a little bit.
Absolutely. The Roman telescope will be a powerful tool for studying dark energy, which is thought to be responsible for the accelerating expansion of the universe.
Right.
It's one of the biggest puzzles in cosmology today.
Yeah.
And the Roman telescope could help us unlock its secrets.
It's really incredible to think that we're living in a time when we can build telescopes that not only peer back to the dawn of time,
Right.
but can also probe those fundamental forces shaping the universe. It's a testament to human ingenuity, our insatiable curiosity about the cosmos.
Absolutely. And that curiosity drives us to explore, to push those boundaries of knowledge, to seek answers to those big questions that have fascinated humans for millennia. Where do we come from? Are we alone in the universe? What is our ultimate destiny?
These are profound questions. And while the JWST and its successors may not provide all the answers, they offer a glimpse into the vastness and complexity of the universe, inspiring us to keep searching.
Yeah, and as we explore, as we learn more about the universe and our place within it,
Right.
we gain a deeper appreciation for our own planet.
It's a humbling perspective,
It is.
reminding us that we are part of something much larger than ourselves.
Yeah.
And we have a responsibility to protect this pale blue dot we call home.
Absolutely. And those JWST images, those breathtaking views of distant worlds, stars being born, galaxies colliding,
Yeah.
it's a powerful reminder of the interconnectedness of all things.
As we wrap up this deep dive into the James Webb Space Telescope, we hope you're leaving with a sense of awe and wonder, a renewed appreciation for the beauty and complexity of the universe, and a thirst for more knowledge.
It's an incredible journey, and it's only just beginning. The JWST will continue to observe the universe, sending back data that will lead to even more amazing discoveries in the years to come.
So stay curious, keep exploring, and never stop asking those big questions. Who knows what wonders await us in the vast expanse of space? That's a wrap for this episode of The Deep Dive. We hope you enjoyed our exploration of the James Webb Space Telescope, a telescope that is truly pushing the boundaries of human knowledge and revealing a universe more vast and awe-inspiring than we ever imagined. Until next time, keep looking up, keep exploring, and never stop reaching for the stars.